We are in the 25th topic, which is the last topic in your end of term exam syllabus. So, this will be the writing topic, the last writing topic in your part 3. There are two more writing topics, which are the bonus questions, which can be anything that we learned throughout the term. So, now over here, this is on related rates. It's all application questions. You need to understand the question thoroughly, and then you need to try to make a figure and then solve the problem. Now, over here, they have asked, suppose a 6 feet tall person is moving away from 18 feet lamppost, and the person moving away from the lamppost is at a rate of 2 feet per second. What is the rate of in the length of the shadow that is changing? Now, we should understand by a figure. Now, this is a figure. A huge lamppost is there. This guy is the person. Now, the shadow, see, this is the light that is falling, and the shadow is somewhere over here. He is moving at a rate of 2 feet per second. What exactly does that mean? Now, over here, since it's related rates, we differentiate with respect to time. It's implicit differentiation over here. So now this is x, right? Length. It is dx by dt. Okay, that is given to be 2 seconds. Why? Because the rate of change, that is the thing. Okay, they did not give you the length. They did not tell the length x is something. No, it is dx by dt. It is very important to understand. Now dx by dt, or x dash value, is given to be 2 feet per second. Now what do we need to find? The rate of changing in the shadow. So now this figure helps us to find it out. There are many ways to solve it, but the easiest way is to know this is, to compare the related parts of the triangle. Now, this over here, this would be similar triangles, isn't it? Over here and over here. Since they are sharing sides, it'll be a similar triangle. Now, from the parts of the similar triangle can be written like this: 18 divided by 6 will be equal to, now this is the big length, so what is the big length over here? X is the distance from lamppost to the person, and S is the shadow. The total length will be X plus S. And what is the small triangle length? That is only S. So now you can rearrange this and write everything in terms of X. You need to find the derivative of X. So take everything to the other side, keep X at one side. You can do it like this. Say, now 18 divided by 6 can be simplified to be 3 equals 3 over here. I'll take this s to the other side, it'll be 3s equals x plus s. And take this s to the other side, it'll be 3s minus s, 2s equals x. Or x is equal to 2s. That is how we can get it. Or there is another way, that is using tan theta. You know, tan theta is opposite by adjacent. So 18 divided by x plus s. Same way over here, the angle is same, isn't it? 16 divided by s. These can be equated and the answer will be same, whichever method you do. See, the answer is x is equal to 2s. They are writing everything in terms of t because it's related rates. Now differentiate this. Now, since there are two functions, implicit differentiation, what happens over here? X dash only. Here 2 is constant, S dash. That's it. So differentiation is straightforward. Now substitute the values back. Which is the value known? 2 feet per second. So substitute over here 2 feet per second. That is 2. Over here is 2. So rearrange and write S dash would be 1 feet per second. Now, since he's going that side away, it'll be positive. So it is increasing by a rate of 1 feet per second. As is going, the shadow is increasing. So this is how we solve this problem. We will see one more problem over here. Sand is poured into a conical pile with a height of pile equaling the diameter of the pile. If the sand is poured at a constant rate of 5 meter cube per second, at what rate is the height of the pile increasing when the height is 2 meter? Now what this means is, let's understand this in a figure. This is very important. The height of pile is equaling the diameter. Now this is a conical pile and sand is being poured. So the volume of the sand is keeping on increasing. See, now this is the base, this is the radius. The height is the diameter, that is d. We know radius is equal to diameter by 2, or 2 radius is equal to diameter, right? This is given, but it is not d, that is h, because they have told height is equal to diameter. This is important. Okay, and then they have told us the sand is poured, the rate of pouring is 5 meter cube per second, and the rate, at what rate the height of the pile is increasing when the height is 2 meters. That means when the height is 2 meter, what is the uh, height increasing? The rate of height must be solved. We will see now one by one. The given values are over here. Height h, radius is h by 2, which we just saw. Why? Because h is the diameter. Now dv by the change in the volume, that means the constant rate of pouring, right? The change in the volume is 5 meter cube per second. It's increasing by 5 meter cube per second. We need to find the rate of change of height dh by dt at the height of 2 meter. We just don't want the value. We need to find it at this particular instant. We will see now. So over here, what is the shape? It's a conical shape. So volume of the cone is given by 1 by 3 pi r square h. So you must remember this formula. Sometimes it might be given, but in this case it's not given. So you must know this formula. And now you know what is V, right? V equals 1 by 3 pi r square h. You know dv by dt. So derive this differentiation. But before differentiation, sorry, you can't do like with all this v unknown, r unknown, h unknown. No, try to get implicit differentiation means you need to have two variables, right? So just rearrange this r and write in terms of h. What I mean is, we know r is h by 2, isn't it? Given in the question. Height equals the diameter. So instead of r, write h by 2 and the square. See, like this. Now what happens is h by 2 the whole square. Now over here you can square both the sides. Square both. H square divided by 2 square is 4. And now rearrange this and write. Over here it will be 1 by 12 pi h cube t. So now this is the volume, rate of change of volume in terms of h. Okay, it's h cube. Why? Because you squared both the sides, you multiplied h. Over here 1 by 12, multiply 3 and 4. 3 and 4. Now this is the rate of change of volume with respect to, this is the volume with respect to time. I'm so sorry. It's the volume, it's not the rate of change. We need to find the rate of change of volume by differentiation. It'll be v dash h dash. So what do you do? dv by dt equals pi by 12. Now this is the constants we are removing out. Now this will be done by chain rule. First do for the 3, that is 3 comes down, h square t, and then derive the ht function, that is dh by dt. So now this is what we have done from the conical formula, deriving it. So you know the conical formula is v equal, volume of the cone is v equal 1 by 3 pi r square h. What you need to apply is, instead of radius, write everything in terms of h, the height, and then solve it, simplify it. Now derive both the sides implicitly with respect to time. We get this. Now that means we know many things, right? V dash we know, that is 5. Now substitute everything back. Now this is just simplification over here. 3 and 12 cancels out to be 5 by 4. H square, h dash is this. Now we need to just substitute over here. That is dv by dt is 5, and h over here is known. H they have told we need to find the rate of height at what? At height of 2 meters. So all we need to do is 5 pi by 4. H will be 2. So 2 square into h dash. This h dash is what we need to solve for. Take everything to the other side. Just take everything to the other side. Solve it. It'll be 1.59 meter per second. So the rate, the height is increasing by 1.59 meter per second when the height is 2 meters. So this is how we can solve it up. Now everything will be given. You need to substitute and solve it. This was done just a while ago. Now over here there is a part B question. What they have asked over here is basically if the person is walking in the other direction, see he's walking towards the lamp, and the rate has also changed 3 feet, same like what was done over here, sorry, same like what was done over here, just that this rate of change will be minus because he's coming in the opposite direction. So that's why it's minus. Okay, so all you need to do is x dash is how much over here? Minus 3, same like what we had seen in the first problem, but it'll be minus 3 by 2 or 1.5 feet per second, negative because this is in the opposite direction. So this direction matters. And over here we have about Boyle's law. This is again a simple one. I'll just tell you briefly. There's a formula given, PV is equal to C, that is Boyle's law, and then pressure, that's about pressure, volume. Now P is the pressure, V is the volume, and C is the constant. Now what you need to do is they have asked you to derive pressure, rate of change of pressure divided by rate of change of volume must be equal to this. You have the formula, isn't it? Just derive it. P will be P dash. Now this, oh sorry, you need to use the chain, the product rule. U dash V plus U V dash. So you can, or you can use this first over here, U V dash plus U dash V. Okay, this whichever can be used. Over here, this is used, the second version. P is written as it is, derive V plus derive P and multiply by V equals 0. Now over here, you are just rearranging and getting towards, get the P dash over here. See, keep this over here as it is, take the other terms to the other side. So what happens is P dash T, I'll just write P dash, and V equals minus P into V dash. Get V dash to the other side and take this to the other side. P dash divided by V dash equals minus P divided by V. Now, this is okay. This is the pressure divided by the volume. What do we have to write it in terms of? C and V. So V, let it be. In the denominator, it's fine. But what is P over here? P is C divided by V, isn't it? So just instead of this P, put C divided by V. You're substituting, it'll be minus C by V square. So that is the answer with respect to time. So that's what we have got. Similarly, you can try the next one. Over here, again, they have told about, again, differentiation. Just the same thing what we have done. See, compare. Now, over here, you need to derive P dash with respect to volume. So what this means is, now function f of x, now you are 1 by x. What is the answer? You derive this minus 1 by x square, right? Same way they have told differentiate pressure, differentiate this with respect to volume, sorry. Differentiate this with respect to volume. This is constant, but this will be derived and you will have to solve. It'll be same thing, see, minus C by V square, like minus 1 by x square, but V is the derivative. And this will be just P dash V. And then compare the answers. The answers will be the same thing, see. That's what. Similarly, please do try the other problems. Now, over here, the figure is given, but the figure won't be given in the exam. You need to do the figure. And then now over here, you have to use Pythagoras theorem and solve it up. Similarly, you can try the other problems. Just make sure you understand, go through it properly. And depending on the shapes, now here it's conical shape, use the cone. If it's spherical, use the sphere, and solve them by yourself and check for the answers.